Look up at the night sky. It's a vast, dark canvas sprinkled with countless points of light. On a clear night, you'll see countless stars, each one a distant sun, blazing away in the vast expanse of space. These stars are not just distant suns, they are ancient beacons, some of which have been shining for billions of years. These twinkling points of light are not merely decorations on the celestial canvas, but rather powerful engines of creation and destruction. They are the cosmic furnaces where elements are forged, the bringers of light and heat, and ultimately the progenitors of life itself. Within their fiery cores, stars create the very elements that make up planets, oceans, and even life. The light and heat they emit travel across the cosmos, reaching us here on Earth, allowing us to glimpse their brilliance. And it is this light and heat that have made life possible on our planet, nurturing it from the very beginning. Their story is one of incredible transformations, a cycle of birth, life, death, and rebirth that has been playing out for billions of years. Stars are born in vast clouds of gas and dust, live out their lives burning brightly, and eventually die, often in spectacular explosions. We often think of stars as eternal and unchanging, but they are not. Each star has a life cycle, a journey from birth to death, just like us. This journey is marked by stages of development, from the initial spark of nuclear fusion to the final dramatic end. A star's life is a testament to the incredible forces at work in the universe, shaping and reshaping the cosmos. But unlike our fleeting time on Earth, a star's life unfolds over millions, billions, even trillions of years. This immense timescale allows stars to witness the unfolding of cosmic history, from the birth of galaxies to the formation of planets. This is the story of those stellar lives, a cosmic drama that plays out on a scale almost too vast to comprehend. As we gaze up at the night sky, we are reminded of our place in this grand, ever-evolving universe, and the stars that light our way. Stars are born in the cold, dark depths of space, within immense clouds of gas and dust known as nebulas. These regions, often appearing as ethereal and ghostly shapes, are the cradles of stellar creation, where the building blocks of the universe come together in a cosmic dance. These nebulas, often called stellar nurseries, are the birthplaces of stars. Within these vibrant and colorful regions, the process of star formation unfolds over millions of years, hidden from our eyes by the vast distances and the dense clouds of gas and dust. Imagine a swirling cloud of hydrogen and helium, remnants of the Big Bang, along with heavier elements scattered from previous generations of stars. These elements, forged in the hearts of ancient stars, are the seeds from which new stars will grow. Within these clouds, gravity acts as a sculptor, pulling together clumps of gas and dust. Over time, these clumps grow larger and more massive, their gravitational pull becoming stronger and drawing in even more material from their surroundings. As these clumps grow denser, they heat up, their internal pressure increasing as they fight against gravity's relentless pull. This heating process is crucial, as it sets the stage for the next dramatic phase in the birth of a star. This battle between gravity and pressure continues until a critical threshold is reached. At this point, the core of the clump becomes so hot and dense that a remarkable transformation occurs. The core of the collapsing cloud becomes so hot and dense that nuclear fusion ignites. This is the moment when a star is truly born, as the fusion process releases an enormous amount of energy, lighting up the surrounding nebula. Hydrogen atoms, the simplest and most abundant element in the universe, are fused together under immense pressure, creating helium and releasing a tremendous amount of energy. A star is born. This new star will shine for millions or even billions of years, a beacon of light in the vastness of space, continuing the cycle of creation and destruction that has shaped our universe since the beginning of time. Once a star ignites nuclear fusion in its core, it enters what is known as the main sequence, the longest and most stable period of a star's life. Our own sun, a yellow dwarf star, is currently in its main sequence, happily fusing hydrogen into helium and bathing the solar system in light and warmth. During this phase, a star exists in a state of equilibrium. The outward pressure from nuclear fusion in its core perfectly balances the inward pull of its own gravity. This delicate balance can last for millions, billions, or even trillions of years, depending on the star's mass. Massive stars, with their greater gravitational pull, burn through their fuel much faster, leading to shorter but more spectacular lives. Eventually, every star, no matter its size, will exhaust the hydrogen fuel in its core. When this happens, the outward pressure from fusion lessens, and gravity begins to win the battle. The core contracts and heats up, while the outer layers of the star expand dramatically, transforming it into a red giant. These bloated stellar giants can swell to hundreds of times their original size, engulfing any nearby planets in the process. Our own sun will eventually become a red giant, its outer layers expanding beyond the orbit of Earth. While this event is billions of years in the future, it is a stark reminder of the impermanence of even the most seemingly eternal objects in the universe. Section 5. The fade to white end of a stellar life. For stars like our Sun, the red giant phase is a prelude to a more peaceful end. As the core continues to contract, it eventually becomes hot enough to fuse helium into heavier elements, such as carbon and oxygen. But this is a temporary reprieve. Eventually, the core runs out of helium as well. With no more fuel to burn, the outer layers of the star are gently puffed away into space, forming a beautiful glowing cloud of gas and dust known as a planetary nebula. The core, now exposed, is incredibly hot and dense, a white dwarf star. This stellar ember will slowly cool over billions of years, fading away into a black dwarf, a cold and inert remnant of a once mighty star. Section 6. Supernovae, the universe's grand finale. While stars like our Sun end their lives relatively peacefully, massive stars go out with a bang, a spectacular explosion known as a supernova. These cosmic detonations are among the most energetic events in the universe, briefly outshining entire galaxies. As a massive star exhausts its fuel, its core collapses under its own immense gravity. This collapse happens so rapidly that it triggers a shockwave that rips through the star, blasting its outer layers into space. The core, depending on its mass, will either become a neutron star or collapse further into a black hole. Section 7. Neutron stars, cosmic lighthouses. Neutron stars are the remnants of massive stars that have exploded as supernova. These objects are incredibly dense, packing more mass than our Sun into a sphere just a few miles across. A teaspoonful of neutron star material would weigh billions of tons on Earth. Some neutron stars, known as pulsars, spin rapidly, emitting beams of radiation from their poles. These beams sweep across space like cosmic lighthouses, their regular pulses detectable from Earth. Pulsars are incredibly precise timekeepers, rivaling the accuracy of atomic clocks. Section 8. Black holes, mysteries of the universe. If the core of a collapsing star is massive enough, it can collapse beyond the neutron star stage, forming a black hole. These objects are so dense and their gravitational pull so strong that nothing, not even light, can escape their grasp. Black holes are regions of space-time where gravity is so intense that it warps the fabric of the universe. They are still shrouded in mystery, but we know they play a crucial role in the evolution of galaxies, often found at the centers of galaxies, holding them together with their immense gravity. Section 9. From death, life, the cosmic cycle. This is the story of how the universe recycles itself, transforming death into the seeds of new life. The death of a star, whether a gentle fade over millions of years or a violent explosion in a supernova, is not the end but rather a new beginning. These cataclysmic events are the universe's way of renewing itself. The elements forged in the cores of stars during their lifetimes, such as carbon, oxygen, and iron, and those created in the fiery crucible of supernovae like gold and uranium, are scattered across the cosmos. This cosmic dust, rich with elements, travels through space, sometimes for billions of years. These elements, the building blocks of planets and life itself, coalesce in the swirling disks of gas and dust around young stars, will eventually become part of new stars, new planets, and potentially new solar systems, and perhaps even new life. The cycle of stellar death and rebirth is a continuous process, ensuring the universe remains dynamic and ever-changing. The iron in your blood, which carries oxygen to your cells, the calcium in your bones, providing structure and strength, the oxygen you breathe, all were created in the hearts of stars that lived and died long ago. These elements are the remnants of ancient stars, now part of us. We are literally made of star stuff, a poetic yet scientific truth connected to the cosmos through this grand cycle of stellar death and rebirth. Every atom in our bodies has a cosmic origin. As we gaze up at the stars, we are not just looking at distant suns. We are looking at our own cosmic origins, a reminder that we are all part of something far greater than ourselves. The universe is within us, and we are within the universe. This interconnectedness is a humbling and awe-inspiring realization, reminding us of our place in the grand tapestry of existence.